So we want to see what are the possible general forms of 3 by 3 matrices in a reduced row echelon form based only on position of leading one and zeros above and below and before the leading ones. So there are a few rules for reduced row echelon form. We kind of need to review that. The first rule is that all the rows that are all zeros are below the rows that have non-zero entries. The second one is basically the first non-zero entry in each row, that's called pivot, is basically one. It's the number one. Here is number one, and that's called leading one. And then the last rule is that all entries above and below the leading one are going to be uh, zero, and the ones before that also have to be zero. And the last rule, but not the least, is every leading one is to the right of the leading one before it. So you basically are moving to right as you go down. So these are loosely put, but let's use them to find all the different forms of 3 by 3 RREF. So one thing is obvious. When I have rows of all zeros, that's three zeros, this has to be on the bottom. And then basically having rows of all zeros restricts the number of leading ones. So most people do it according to that. And so not quite that, but the opposite of that. And they say, hey, I'm going to find all the ones in rank 3, which has no rows of all zeros. Then I'll find all the ones in rank 2, and then I find all the ones in rank 1. And then it becomes uninteresting because if it's all zeros, which is rank 0, we don't care at that point. So basically, when it's rank 3, I know that at each row I have a leading 1. And that means that let's look at the columns. Uh, the only way that I can do this, there are 3 columns, and I cannot have 2 leading ones in any of the columns. So basically, I have to start one in here, because the zeros above and below, right? And then one here. And then I know that below this has to be 0, and above and below this has to be 0 and 0. And that's the only way I could do a rank 3. Now let's see rank 2. For rank 2, I can have a row of all zeros, which has to be in the bottom. Then I will have 2 leading one, but for each row. So looking at the columns, because every column can have only one, I can have this way, or I can have this way, or I can have uh, these 2 columns to be leading one. Is there anything else left? No. That's the only options that I actually have. And so if this is the leading one here, then it has to be here, above it 0, below it 0. Um, in here, I don't know what's going to happen. You don't have to put in different variables in there. There are all sort of variables can be there, but you don't have to do that. In here, if I put in a 1 in here and a 1 in there, then there is a 0 above and a 0 below, and then there is a 0 before this leading one. The only thing that I don't know is that. Now, when I'm trying this, basically I have a leading one here and I have a leading one here. Again, do you see that just as I move down, I go to the right? And above and below are 0. and then and over here before is 0 and before is 0. And so what are the options? What are the options left? Rank 1, so I have to have 0, 0, 0, 0, 0, 0. So multiple ways can happen. One can appear here, and then I don't know what's going on in here. I have no idea. Or I can have a leading one here, which I know 0 has to be here, but I don't know what's happening there. And then the last way that I can have it is the last column. So I will have 0, 0, 1. And that's all given. So overall, I will have how many? I have 3 plus 3 plus 1, 7 different ways of REF for 3 by 3. And again, if you really want to add the rank 0, the matrix that you get is all zeros, the uninteresting one, and they add up to 8 forms.